Hello there, and welcome. Tonight I want to take you somewhere special, somewhere beyond the gentle glow of your bedside lamp, beyond the familiar walls of your room, beyond even the soft blanket of Earth's atmosphere that cradles us all. Tonight we're going to drift together into the vast quiet spaces between worlds, where an ancient traveller has been making its way toward us through the darkness for longer than human civilization has existed. This visitor, known to astronomers as Comet C2019Y4, or simply Atlas, might at first seem like nothing more than a wandering chunk of ice and rock, one of countless such objects that drift through our solar system. It's a notion that might make you shrug, might make you think this is just another story about space rocks and orbital mechanics. But what if I told you that this particular visitor might be something more? What if, in the crystalline structure of its ancient ice, in the very atoms that compose its being, there exists a kind of memory, a record of everything it has witnessed on its long journey through the cosmos, including perhaps, just perhaps, a record of us. Consider for a moment the nature of observation itself. When you look at something, when light bounces off an object and enters your eyes, you're engaged in a fundamental exchange of information with the universe. The photons that carry the image to your retina have physically interacted with whatever you're observing. They've been changed by that interaction, and in turn, they change you by creating an image in your mind. This isn't mysticism or speculation. This is the fundamental nature of how information moves through our universe. Every interaction, no matter how small, leaves a trace, creates a record, becomes part of the ongoing story of existence. And if this is true for the simple act of seeing, imagine what might be true for a comet that has been traveling through space for millions of years, constantly bombarded by particles and radiation from every corner of the cosmos, including from our small, blue world. Atlas first appeared to us as a faint smudge in the darkness, discovered on December the 28th, 2019, by the Asteroid Terrestrial Impact Last Alert System in Hawaii. The astronomers who found it were simply doing their job scanning the sky for potentially hazardous objects, cataloguing the various rocks and ice balls that cross Earth's neighbourhood. But even in those first observations, there was something intriguing about this particular comet. Its orbit suggested it was a long-period comet, meaning it takes thousands or even millions of years to complete a single journey around the Sun. This wasn't just a visitor from the outer solar system. This was a messenger from the deep freeze beyond Neptune, from the Oort cloud, that vast spherical shell of icy objects that surrounds our solar system like a cosmic snow globe. As we settled into our beds tonight, as we pulled our blankets up to our chins and closed our eyes, Atlas continued its eternal dance through the darkness. Even now, as these words float through your consciousness, the comet's journey continues, though in a form quite different from when it was first discovered. You see, Atlas underwent a transformation, a fragmentation that scattered its ancient body into countless pieces, each carrying with it whatever memories, whatever records, whatever impossible archives might have been encoded in its crystalline structure. But we're getting ahead of ourselves. Let's return to the beginning, to that moment when this ancient traveller first began to capture our attention and our imagination. The name Atlas itself carries a certain poetry, doesn't it? In Greek mythology, Atlas was the titan condemned to hold up the heavens for eternity, bearing the weight of the celestial sphere on his shoulders. Our comet Atlas, in its own way, might be bearing a different kind of weight, carrying not the physical heavens but perhaps the informational weight of everything it has encountered in its travels. Every star whose light has touched its surface, every cosmic ray that has penetrated its icy shell, every gravitational tug from distant worlds. All of these interactions might have left their mark, might have been recorded in ways we're only beginning to understand. Think about ice for a moment. Not the ice in your freezer or the frost on your window, but ice in its most fundamental form. Water molecules arranged in crystalline patterns, each molecule locked in place by hydrogen bonds, creating structures of remarkable complexity and beauty. scientists have discovered that ice can store information in its crystal structure, that impurities and variations in the crystalline lattice can encode data about the conditions under which the ice formed and everything that has happened to it since. The ice cores we drilled from Antarctica tell us stories about Earth's climate going back hundreds of thousands of years. Each layer contains trapped air bubbles, volcanic ash, cosmic dust, a detailed record of our planet's history written in frozen water. Now imagine ice that formed not on Earth but in the vast emptiness between stars, ice that has been travelling through space since before our sun was born, ice that has been exposed to phenomena we can barely imagine. Atlas, like all comets, is primarily made of ice, but not just any ice. This is primordial ice, formed in the earliest days of our solar system or perhaps even before, in the cold molecular clouds that gave birth to our sun and planets. This ice has never known warmth, never experienced the cycle of melting and freezing that shapes ice on Earth. It has remained in its original state for billions of years, a perfect time capsule from the dawn of our cosmic neighbourhood, and during all those eons it has been quietly accumulating information, recording the subtle influences of gravity, radiation and magnetic fields from across the galaxy. When we talk about recording, we usually think in terms of human technology, of cameras and microphones, hard drives and memory chips. But nature has its own ways of storing information, ways that predate any human invention by billions of years. DNA, for instance, is nature's own data storage system, encoding the instructions for life in molecular sequences. Rocks record the magnetic field of Earth at the time they formed, preserving a record of our planet's magnetic history. Tree rings encode information about climate and growing conditions. Even the cosmic microwave background radiation, that faint echo of the Big Bang that fills all of space, is a kind of record, a fossil of the universe's earliest moments. Why should we assume that a comet travelling through space for millions of years wouldn't also be recording information in its own way? The trajectory of Atlas brought it from the outer darkness toward the inner solar system, toward the warmth of our sun and the bustling neighbourhood of the rocky planets. As it approached, something remarkable began to happen. The comet began to brighten, not gradually as astronomers expected, but dramatically, unexpectedly. For a brief moment in early 2020, it seemed as though Atlas might become visible to the naked eye, might grace our night sky with a celestial show not seen for years. People around the world began to prepare. Amateur astronomers dusted off their telescopes, photographers planned their shots, and children learned about comets in their science classes. There was a sense of anticipation, of connection to something ancient and mysterious. But then, just as unexpectedly as it had brightened, Atlas began to fragment. The solid nucleus that had remained intact for perhaps millions of years began to break apart, scattering into pieces that continued along slightly different paths. To many observers, this was a disappointment. The celestial show they had hoped for would not materialize. But what if this fragmentation was not a failure but a fulfillment? What if the comet had completed its mission of observation and was now dispersing its collected data across a wider area of space, like a dandelion seed head scattering its seeds on the cosmic wind? As you lie there in the darkness, perhaps you can feel the weight of your own observations, the accumulated experiences of your day settling into memory. Every person you encountered, every word you spoke, every thought that crossed your mind, all of it becoming part of the record of your life. We're all in our own way recording devices, storing information about our journey through existence. And if we, with our brief lives and limited perspectives, can accumulate such rich archives of experience, imagine what a comet travelling for millions of years might collect. The idea that we might be under observation, that our actions and existence might be recorded by a passing comet, could seem unsettling at first. But there's something deeply comforting about it too, something that connects us to the larger cosmos in a profound way. If Atlas or comets like it are indeed recording information about our world, then we are not alone in the universe, not in the sense of alien civilizations watching us, but in the sense that the universe itself is paying attention, that our stories matter enough to be preserved in the crystalline memory of ancient ice. Consider the electromagnetic signals that constantly emanate from our planet. Radio waves, television broadcasts, cellular communications, Wi-Fi signals, all of it radiating outward at the speed of light, creating an expanding sphere of information that now extends more than 100 light-years from Earth. Our earliest radio broadcasts have already passed thousands of stars, carrying with them the voices, music, and stories of humanity into the cosmic darkness. These signals are weak, incredibly weak by the time they've travelled even a few light years, but they exist, they're real. They're part of the physical universe, and anything passing through this sphere of signals, whether it's an alien spacecraft or a wandering comet, would be bathed in this electromagnetic whisper of human civilization. Atlas passed through the inner solar system, just as humanity was experiencing one of its most globally synchronized moments in recent history. The early months of 2020 saw the world grappling with a pandemic, saw billions of people altering their daily routines, saw a planet-wide shift in human behavior that was unprecedented in modern times. If there was ever a moment when the electromagnetic signature of Earth might have carried a unique pattern, a distinctive signal of a species facing a common challenge, it was during Atlas's closest approach. The comet arrived just as we were all looking inward, staying in our homes, communicating through screens, creating a different kind of electromagnetic chatter than ever before. But let's pull back from the specific and think about the general principle at work here. Information, as physicists understand it, cannot be destroyed. It can be transformed, it can be scrambled, it can be dispersed, but it cannot simply vanish from the universe. This is one of the fundamental principles of quantum mechanics, encoded in something called the unitarity of quantum evolution. What this means, in simpler terms, is that everything that happens leaves a permanent mark on the universe, even if that mark becomes increasingly difficult to read over time. The conversations you had yesterday, the dreams you dreamed last night, the thoughts passing through your mind right now, all of them create ripples in the electromagnetic field, tiny perturbations that propagate outward, becoming part of the permanent record of the cosmos. Now, you might wonder how a comet, even one with ice that could theoretically store information, could actually detect and record the complex electromagnetic signals from Earth. This is where we must let our imagination dance with possibility while staying grounded in scientific principle. We know that cosmic rays, high-energy particles that constantly bombard everything in space, can create cascades of secondary particles when they strike matter. These cascades can be influenced by magnetic fields and electromagnetic radiation, creating patterns that depend on the local electromagnetic environment. If a comet passes through Earth's extended electromagnetic sphere, the pattern of cosmic ray cascades in its ice might be subtly different than if it were travelling through empty space. These differences might be incomprehensibly small, might require technology far beyond our current capabilities to detect and decode, but they would exist. There's also the phenomenon of quantum entanglement to consider, that spooky connection between particles that Einstein himself struggled to accept. Every particle that strikes the comet's surface, every photon absorbed by its ice, becomes quantum mechanically entangled with the comet's material. And since some of those particles and photons originated from Earth, carried information about our world, there exists, at least in principle, a quantum connection between Atlas and our planet. This isn't science fiction or New Age mysticism. This is mainstream quantum mechanics, though admittedly pushed to its speculative limits. As the night deepens around you, as your breathing slows and your mind begins to drift, think about the journey Atlas has taken to reach us. It began its inward fall from the Oort cloud perhaps millions of years ago, nudged by the gravitational influence of a passing star or the subtle tidal forces of the galaxy itself. For most of that journey, it travelled in perfect darkness and perfect cold, so far from the sun that our star would have appeared as nothing more than a particularly bright point of light, indistinguishable from the countless other stars in the sky. The comet moved with patient purpose, following the inexorable pull of gravity, tracing an elliptical path that would eventually bring it into the warmth and light of the inner solar system. During those long eons of approach, Atlas was not idle. Even in the vast emptiness between stars, space is not truly empty. It's filled with a thin soup of particles and radiation, the detritus of stellar explosions, the whispers of distant galaxies, the quantum foam of space-time itself. All of this would have interacted with the comet, each interaction potentially leaving its mark, adding another line to the cosmic journal that Atlas might represent. The comet would have passed through regions of space where ancient supernovae had enriched the interstellar medium with heavy elements, through magnetic fields generated by the galaxy's rotation, through streams of particles flowing from distant stellar winds. And then, as Atlas fell deeper into the solar system's gravity well, the pace of its journey quickened. What had been a leisurely drift through the cosmos became a headlong rush toward the sun. The comet began to feel the solar wind, that stream of charged particles constantly flowing outward from our star. Its icy surface, which had remained unchanged for eons, began to sublimate, transforming directly from solid to gas as the sun's heat reached it. This created the comet's coma, that glowing cloud of gas and dust that surrounds the nucleus, and its tail, that banner of light that always points away from the sun, pushed by the pressure of sunlight and solar wind. This transformation is crucial to our contemplation tonight. As the comet's ice sublimated, as its ancient surface was exposed to the sun for perhaps the first time in its existence, any information encoded in that ice would have been released, scattered into space along with the gas and dust. If we imagine Atlas as a cosmic recording device, then its passage through the inner solar system was like playing back that recording, broadcasting its accumulated memories into the void. The fragments of the comet that resulted from its breakup would each carry portions of this record, like pages torn from an ancient book, each piece holding part of the story but none containing the whole. The timing of Atlas's arrival and fragmentation seems almost poetic when considered from this perspective. It came to us during a time of global uncertainty, when humanity was questioning its future, re-evaluating its priorities, and discovering new ways to connect despite physical distance. The comet's brightness gave us hope for a celestial spectacle that might unite us in wonder, and even its fragmentation became a metaphor for the challenges we were facing, the breaking apart of old systems and assumptions. If Atlas was indeed recording our electromagnetic emanations, it captured us at a unique moment in our history, a moment of vulnerability and resilience, of isolation and solidarity. But we should be careful not to anthropomorphize too much, not to imagine that Atlas or any comet has intentional consciousness. If these objects are recording information, they're doing so passively, automatically, the way a rock records the direction of Earth's magnetic field when it forms, or the way tree rings record rainfall patterns. The recording happens not because the comet chooses to observe, but because observation, in the quantum mechanical sense, is simply what happens when any two parts of the universe interact. Every particle that touches another particle, every wave that propagates through space, every gravitational influence that tugs on a distant object, all of these are observations. All of these are exchanges of information that leave permanent marks on the fabric of reality. This brings us to a profound realization about the nature of existence itself. If every interaction is an observation, if every observation leaves a record, then the entire universe is, in a very real sense, a vast recording device, constantly documenting its own evolution, constantly writing its own history in the quantum states of its constituent particles. We are not separate from this process. We are part of it. Every breath you take, every thought you think, every dream you dream becomes part of this cosmic record. Atlas, in this view, is not an alien observer, but a fellow participant in the universe's endless documentation of itself. As you settle deeper into sleep tonight, let your mind drift with Atlas on its journey. Imagine yourself not as a separate observer watching the comet, but as part of the same cosmic dance, both of you recording and being recorded, observing and being observed. There's a deep peace in this recognition, a sense of belonging to something infinitely larger than ourselves, yet intimately connected to our smallest actions and thoughts. The electromagnetic whispers of our civilization that might have washed over Atlas are the same whispers that connect you to everyone else on this planet, the same signals that carry our collective hopes, fears, dreams, and daily conversations. The ancient ice of Atlas might seem impossibly remote, a frozen artifact from the dawn of the solar system, but the atoms that compose that ice were forged in the hearts of stars that died billions of years ago. The same stellar furnaces that created the atoms in your body. We are, all of us, Earth and Atlas alike, made of star stuff, as Carl Sagan so beautifully put it. The carbon in your cells, the oxygen you breathe, the iron in your blood, all of it was created in stellar nuclear fusion and scattered into space by supernovae, eventually condensing into new stars, planets, and yes, comets. In this sense, Atlas is not an alien visitor, but a distant cousin, another arrangement of the same cosmic materials that compose everything we know and love. The possibility that Atlas might be recording information about our world raises fascinating questions about the nature of memory and permanence in the universe. We tend to think of memory as something biological, something that requires a brain, or at least a nervous system. But what if memory is more fundamental than that? What if the universe itself has a kind of memory, encoded in the quantum states of its particles, in the patterns of its fields, in the very structure of space-time? This isn't as far-fetched as it might sound. Modern physics suggests that information is a fundamental quantity, as basic to the universe as energy or matter. And if information is fundamental, then perhaps memory, the preservation of information over time, is also a basic feature of reality. To truly appreciate the journey of Atlas, we need to step back and contemplate the vast scales of time and space through which this ancient traveller has moved. If we compressed the entire history of the universe into a single year, with the Big Bang occurring at midnight on January 1st, our solar system wouldn't form until September, life on Earth wouldn't appear until sometime in October, and all of human civilization would flash by in the last few seconds before midnight on December 31st. Yet Atlas has been travelling for a significant portion of this cosmic year, perhaps since late September or early October in our compressed timeline, witnessing the formation of planets, the evolution of life, the rise and fall of countless species, all while maintaining its cold, patient orbit through the darkness. The Oort cloud, that vast spherical shell from which Atlas originated, extends perhaps a light year or more from our Sun, a quarter of the distance to the nearest star. To put this in perspective, if the Earth's orbit around the Sun were shrunk to the size of a penny, the Oort cloud would be a sphere about the size of a small city. Within this enormous volume, billions or perhaps trillions of icy bodies drift in near-perfect darkness, so far from the Sun that its light provides no warmth, barely distinguishable from the background stars. These objects are the leftover building blocks of our solar system, pieces that never coalesced into planets, frozen remnants of the primordial disk from which our cosmic neighbourhood formed. Atlas spent most of its existence in this frozen realm, orbiting so slowly that a single revolution around the Sun might take millions of years. Out there, in that profound cold and darkness, time moves differently, or rather our human perception of time becomes meaningless. There are no days or nights, no seasons, no markers of passing time except the slow wheeling of the stars, themselves moving in their own stately orbits around the galaxy. The comet existed in a state of near-perfect preservation, its ice unchanged since it first condensed from the solar nebula, its surface unmarked by erosion or weathering, a pristine sample of the early solar system. But even in this seeming stasis, Atlas was not truly isolated. The galaxy itself was rotating, carrying our entire solar system, Oort cloud and all, on a journey around the galactic centre that takes about 225 million years to complete. During the comet's long residence in the outer darkness, our solar system completed perhaps a dozen of these galactic years, passing through different regions of the galaxy, encountering different stellar neighbourhoods, experiencing the gentle gravitational tugs of passing stars. Each of these encounters, no matter how slight, would have influenced the orbits of Oort cloud objects, occasionally sending one of them falling toward the inner solar system. Think about what Atlas might have witnessed during its approach, had it eyes to see. As it fell inward from the Oort cloud, it would have watched the sun grow from just another star to a distinct disk, would have seen the outer planets emerge from points of light to worlds with visible features. Jupiter would have swelled from a bright star to a banded giant, its great red spot a visible eye staring back at the approaching comet. Saturn's rings would have resolved from a blur to their magnificent structure, a cosmic work of art that never fails to inspire wonder. The comet would have passed through regions of space where humanity has sent its robotic emissaries, might have crossed the paths of the Voyager spacecraft, those ambitious messengers we've dispatched to carry information about our species to the stars. The timeline of Atlas's journey intersects with human history in fascinating ways. When the comet last approached the inner solar system, if indeed it ever has before, humans might not have existed at all. Depending on its orbital period, its previous visit might have occurred when dinosaurs walked the Earth, or when the planet was covered in ice, or when life was nothing more than simple, single-celled organisms in primordial seas. The Earth that Atlas observed on this most recent approach would have been unrecognizable from its previous visit, transformed by the emergence of a technological species that has reshaped the planet's surface and filled its atmosphere with electromagnetic chatter. Consider the electromagnetic timeline of Earth from Atlas's perspective. For almost all of our planet's history, it was electromagnetically quiet, producing only the natural radio emissions generated by lightning and auroras. Then, suddenly, just over a century ago from our perspective, but mere moments ago in cosmic time, Earth lit up with artificial signals. First came the early radio experiments of the late 19th century, weak signals that nonetheless marked the beginning of something unprecedented in our planet's history. Then came commercial radio broadcasting, television, radar, satellite communications, cellular networks, and now the constant buzz of billions of connected devices. From Atlas's viewpoint, Earth transformed from a quiet world to a radio beacon in the blink of a cosmic eye. This transformation would have been gradual from the comet's perspective as it approached. When Atlas was still in the outer solar system, perhaps passing the orbit of Neptune, the electromagnetic signals from Earth would have been incredibly faint, lost in the background noise of the cosmos. But as the comet drew closer, falling faster and faster toward the sun, these signals would have grown stronger, more distinct. By the time Atlas reached the orbit of Jupiter, Earth's electromagnetic voice would have been clearly audible, so to speak, a complex symphony of signals encoding everything from personal conversations to global positioning data, from streaming videos to financial transactions. The idea that all of this information might be recorded in the structure of cometary ice requires us to think about information storage in ways that push the boundaries of our current understanding. We're familiar with digital storage, with bits and bytes encoded in magnetic fields or electrical charges. We understand analog storage, like the grooves in a vinyl record or the magnetic patterns on a cassette tape. But nature might have storage mechanisms we haven't yet discovered or fully understood. After all, we've only recently learned that certain crystals can store data holographically, that DNA can be used for digital storage, that quantum states can encode information in ways that classical physics never imagined. The ice in Atlas is not ordinary ice, but a complex mixture of water ice, frozen gases like carbon dioxide and methane, and organic molecules, the basic building blocks of life. This ice formed under conditions we can't replicate on Earth, in the near absolute zero of space, under bombardment by cosmic rays and stellar radiation. The crystal structure of this ice might be far more complex than anything we've studied in our laboratories, might contain defects and patterns that could, in principle, encode vast amounts of information. Each cosmic ray strike creates a cascade of atomic displacements. Each photon absorption changes the electronic state of molecules. Each gravitational interaction slightly deforms the crystal lattice. Over millions of years, these tiny changes could accumulate into a detailed record of the comet's journey. As Atlas fell through the solar system, it would have experienced the sun's influence growing stronger with each passing day. The solar wind, that stream of charged particles flowing outward from our star, would have begun to interact with the comet's surface, sputtering away atoms and molecules that had been locked in place for eons. The sun's magnetic field, carried outward by the solar wind, would have enveloped the comet, subjecting it to electromagnetic forces it hadn't experienced in millions of years. And the sun's gravity, growing ever stronger, would have stressed the comet's structure, creating tidal forces that might have contributed to its eventual fragmentation. The fragmentation of Atlas, which occurred in April and May of 2020, was observed by telescopes around the world, and even by some amateur astronomers with modest equipment. What they saw was not a sudden explosion but a gradual coming apart, the nucleus splitting first into a few large pieces, then those pieces fragmenting further, creating a train of icy debris following the same general orbit, but slowly spreading out along the comet's path. Each fragment continued to sublimate, creating its own small coma and tail, like a family of smaller comets, where once there had been one. From our perspective of Atlas as a potential cosmic recording device, this fragmentation takes on a different meaning. If information about Earth and the solar system was indeed encoded in the comet's ice, then the fragmentation didn't destroy that information but distributed it, spread it across multiple carriers. It's like taking a book and tearing it into chapters, each piece still containing part of the story, each fragment carrying its portion of the cosmic record. Some of these fragments continued on paths that took them close to the sun, where they would have completely sublimated, releasing their information into the solar wind to be carried outward to the stars. Others might have been deflected onto new orbits, perhaps to return again in centuries or millennia, perhaps to wander back to the Oort cloud carrying their records with them. The timing of the fragmentation, occurring just as the comet was becoming visible to Earth-based observers, seems almost orchestrated, as if Atlas waited until it had our attention before revealing its true nature. Of course, this is just coincidence, the result of physical forces and material properties, not intention or design. But there's something poetic about it nonetheless, something that speaks to the interconnectedness of all things in the cosmos. The same solar radiation that made the comet visible to us also caused its destruction. The same warmth that activated its nucleus also tore it apart. During its approach and fragmentation, Atlas was observed by some of humanity's most sophisticated instruments. The Hubble Space Telescope captured detailed images of the breaking nucleus, revealing structures and processes never before seen in such detail. Ground-based telescopes equipped with advanced spectrometers analyzed the light from the comet, determining its chemical composition, measuring the gases being released from its surface. Radio telescopes listened for emissions from the comet, searching for signals that might reveal the presence of complex organic molecules. All of this observation, all of this recording of the comet by human instruments, creates an interesting symmetry with our speculation about the comet recording us. Think about the light from Atlas that reached Earth during its approach. Those photons traveled millions of miles through space, carrying information about the comet's composition, temperature, and structure. When they struck the sensors in our telescopes, they created electrical signals that were converted to digital data, stored on hard drives, analyzed by computers, interpreted by scientists, and ultimately transformed into human knowledge about this visitor from the outer darkness. In a very real sense, Atlas succeeded in transmitting information to Earth, even if that information was simply about its own nature rather than observations it might have made of us. The trajectory that brought Atlas into the inner solar system was not random, but the result of a complex interplay of gravitational forces acting over millions of years. Every star that passed within a few light years of the Oort cloud, every massive planet in our outer solar system, even the collective gravity of the galaxy itself, all contributed to nudging Atlas from its stable orbit in the cold darkness onto a path toward the sun. This is a reminder that nothing in the universe exists in isolation, that everything is connected through the fundamental forces of nature, that even the loneliest comet in the most distant reaches of space is part of the cosmic web of interactions. As we contemplate these vast scales of time and space, it's natural to feel small, perhaps even insignificant. But consider this. The same physical laws that govern the motion of Atlas also govern the neurons firing in your brain as you process these words. The same quantum mechanics that might allow ice to store information also underlies your consciousness, your ability to think and dream and wonder. You're not separate from the cosmos, but an integral part of it, a way for the universe to observe and understand itself. When you look up at the night sky and see a comet, you are the universe looking at itself, matter that has become aware, contemplating matter that remains unconscious. The journey of Atlas through time connects us to the deep history of our solar system and our galaxy. The atoms in the comet's ice were forged in stars that died before our sun was born, stars that themselves formed from the ashes of even earlier generations of stars. This process of stellar recycling has been going on for over 13 billion years, each generation of stars creating heavier elements, increasing the complexity of matter, setting the stage for planets and life and consciousness. Atlas is a messenger not just from the outer solar system but from this entire cosmic history, a frozen sample of the processes that led to our existence. In the gentle darkness of your room, as sleep begins to claim the edges of your consciousness, you can imagine yourself connected to this vast timeline, your brief life a single note in a cosmic symphony that has been playing for billions of years and will continue for billions more. The electromagnetic signals that emanate from your devices, the infrared radiation from your body heat, even the gravitational influence of your mass, all of these extend outward into space, becoming part of the permanent record of the universe. Just as Atlas might have recorded something of Earth during its passage, so too does the universe record something of you, preserving in its quantum memory the fact of your existence, your thoughts, your dreams. Chapter 3. The nature of observation, and let us now turn our contemplation to the profound question of what it means to observe and be observed in our quantum universe. As you rest there in the darkness, perhaps with your eyes closed, you might think you're not observing anything at all. But observation, in the deepest sense, doesn't require eyes or consciousness or even awareness. Every particle in your body is constantly observing its surroundings, exchanging photons with nearby atoms, feeling the gravitational pull of distant masses, responding to electromagnetic fields that permeate all of space. You are, in every moment, both observer and observed, part of an infinite web of interactions that constitutes the fabric of reality itself. Atlas, as it journeyed through our solar system, was engaged in this same process of mutual observation. Its icy surface absorbed photons from the sun and from Earth. Particles from the solar wind embedded themselves in its crystalline matrix. Gravitational forces from all the planets subtly influenced its trajectory. Each of these interactions was an observation in the quantum mechanical sense. A collapse of probability waves into definite states, a recording of information in the physical structure of matter. The comet wasn't passively traveling through empty space, but actively participating in the universe's ongoing process of self-observation and self-documentation. Consider the photons that traveled from Earth to Atlas during its passage through the inner solar system. These weren't just random light particles, but carriers of information, electromagnetic waves encoding everything from the reflection of sunlight off our oceans to the artificial illumination of our cities at night, from the heat signature of our forests to the radio broadcasts of our communication networks. Each photon that struck the comet's surface carried with it a tiny piece of information about our world, a quantum of data about the state of Earth at the moment the photon was emitted. And when that photon was absorbed by a molecule in the comet's ice, that information didn't disappear but was transformed, became part of the quantum state of the absorbing molecule. This might seem like an impossibly subtle effect, too small to matter, too fleeting to constitute any kind of meaningful record. But we must remember that Atlas was exposed to countless trillions of such photons during its passage through the inner solar system, each one adding its small contribution to the total information absorbed by the comet. It's like trying to hear a whisper in a noisy room. One whisper might be inaudible, but billions of whispers synchronized together become a clear voice. The collective effect of all those photons, all those particles, all those interactions might indeed constitute a kind of observation, a kind of recording that we're only beginning to understand. The physical structure of Atlas provides a fascinating medium for such potential recording. The comet's nucleus, before its fragmentation, was estimated to be several kilometers across, composed primarily of water ice mixed with frozen gases and dust particles. But this wasn't a uniform ball of ice like you might imagine. Cometary nuclei are complex heterogeneous structures with layers and inclusions that record the history of their formation. They're more like cosmic geology than simple snowballs, with strata that encode information about different epochs in the early solar system. Each layer might have formed under different conditions at different distances from the Sun, incorporating different materials from the primordial nebula. Within this complex structure, there are countless opportunities for information storage. Crystal defects in the ice can trap electrons in quantum states that persist for millions of years. Cosmic ray tracks create permanent damage trails that record the direction and energy of incoming particles. Embedded dust grains might contain magnetic minerals that can record and preserve magnetic field information. Organic molecules, which we know exist in comets, can form complex polymers that could, in principle, encode information in their molecular sequences. The comet, in this view, is not just a passive lump of ice, but a sophisticated recording medium, shaped by nature to preserve information about its journey through space and time. The quantum mechanical nature of observation adds another layer of complexity to our contemplation. In quantum mechanics, observation is not a passive process, but an active one that fundamentally changes both the observer and the observed. When a photon from Earth strikes a molecule in Atlas's ice, both the photon and the molecule are changed by the interaction. The photon ceases to exist as a separate entity, its energy and momentum absorbed into the molecular system. The molecule transitions to a different quantum state, its electrons rearranged, its vibrational modes altered. This change, this transition from one quantum state to another, is a form of information storage, a recording of the interaction in the physical structure of matter. But here's where things become even more interesting. Quantum mechanics tells us that until an observation is made, particles exist in superpositions of states, simultaneously in multiple conditions until the act of observation collapses them into a single, definite state. This means that Atlas, as it approached Earth, existed in a superposition of all possible states consistent with its journey, a quantum blur of possibilities that only became definite through its interactions with photons, particles, and fields from our planet. In observing Earth, Atlas was also being defined by Earth, its quantum state shaped by the information it received from our world. This reciprocal relationship between observer and observed is one of the most profound insights of modern physics. There is no objective, independent reality separate from observation. Reality emerges from the interplay of observations, from the constant exchange of information between all parts of the universe. Atlas and Earth were not separate entities that happened to encounter each other, but parts of a unified quantum system, their states entangled through their mutual observations, their histories intertwined in ways that transcend our classical understanding of space and time. The electromagnetic emanations from Earth that washed over Atlas during its passage carry an incredibly rich spectrum of information about our world and our civilization. At the lowest frequencies, there are the radio waves from our communication systems, encoding voices, music, data streams, the entire digital conversation of our species. At higher frequencies, there's the infrared radiation from our planet's warmth, the visible light reflected from our surface, the ultraviolet absorbed and re-emitted by our atmosphere. Each frequency band carries different information, tells a different part of Earth's story, and all of it was available to Atlas as potential data to be recorded in its icy matrix. Think about what an analysis of Earth's electromagnetic spectrum would reveal to a hypothetical intelligence examining Atlas's recorded data. The regular pulsing of our power grids at 50 or 60 Hz would indicate an organized technological civilization. The complex modulation patterns of our communication signals would suggest language, culture, the exchange of abstract information. The daily cycle of artificial illumination visible from space would reveal our circadian rhythms, our patterns of activity and rest. The seasonal variations in reflected sunlight would tell of our axial tilt, our orbit around the sun, the rhythms of life on our planet. All of this information was there in the electromagnetic waves that bathed Atlas during its approach. But electromagnetic radiation is just one channel through which Earth might have communicated with Atlas. There are also gravitational effects to consider. Earth's gravity, though weak at the distances involved, still exerted a measurable influence on the comet's trajectory. This gravitational interaction is another form of observation, another exchange of information between Earth and Atlas. The precise way the comet's orbit was perturbed by Earth's gravity encoded information about our planet's mass distribution, about the moon's position, about the complex dance of celestial mechanics that governs our local neighborhood. These gravitational observations might seem purely mechanical, but in the framework of general relativity, gravity is the curvature of space-time itself, and gravitational interactions are exchanges of information about the structure of space and time. Then there are the particles to consider, the stream of atoms and molecules that escape from Earth's atmosphere and drift into space. This atmospheric leakage is tiny compared to our planet's total atmosphere, but it's real and continuous. Hydrogen atoms, the lightest and most escape-prone, constantly drift away from the top of our atmosphere. Heavier molecules occasionally achieve escape velocity through various processes. Some of these escaping particles would have encountered Atlas during its passage, would have embedded themselves in the comet's ice or interacted with its coma. Each particle carried information about Earth's atmospheric composition, about the chemical processes occurring on our planet, about the presence of life with its distinctive chemical signatures. The possibility of biological signatures in Earth's emanations is particularly intriguing. Life on Earth has dramatically altered our planet's atmosphere, filling it with oxygen, removing carbon dioxide, creating chemical disequilibria that wouldn't exist on a lifeless world. These biological modifications to our atmosphere affect the spectrum of light reflected and emitted by Earth, create distinctive absorption lines that could, in principle, be detected and recorded. If Atlas's ice contains a record of the electromagnetic spectrum it observed from Earth, that record might include the spectral signatures of chlorophyll, of oxygen, of methane from biological sources, all indicators of a living world. As Atlas approached the sun and began to sublimate, forming its coma and tail, it entered a new regime of observation and information exchange. The coma, that cloud of gas and dust surrounding the nucleus, acted like a natural spectrometer, absorbing and re-emitting light at specific wavelengths determined by its chemical composition. Earth-based telescopes observing this spectrum were essentially reading information that had been stored in Atlas's ice for millions of years. Chemical information about the conditions in the early solar system preserved in frozen form and now released for our instruments to decode. The interaction between the solar wind and Atlas's coma created another layer of observable phenomena. As charged particles from the Sun struck the gas molecules streaming from the comet, they induced fluorescence, causing the molecules to glow at characteristic wavelengths. This glow, visible in our telescopes as the greenish hue typical of comets, was a form of communication, a transmission of information from Atlas to Earth mediated by the Sun's particles. The intensity and spectrum of this fluorescence encoded information about the comet's composition, its rate of sublimation, the density of its coma, all details that our instruments eagerly recorded. But perhaps the most profound aspect of observation is not the physical mechanisms involved, but the meaning we assign to what we observe. When ancient humans looked up at comets, they saw omens, messages from the gods, harbingers of change. When modern astronomers observe comets, they see time capsules from the early solar system, carriers of prebiotic molecules, clues to our cosmic origins. The same physical object, the same stream of photons reaching our eyes or instruments, can carry vastly different meanings depending on the framework through which we interpret them. Atlas, in this sense, was not just a comet, but a mirror, reflecting back to us our own evolving understanding of the cosmos and our place within it. The fragmentation of Atlas added a dramatic chapter to this story of observation. As the nucleus broke apart, fresh surfaces were exposed to sunlight for the first time in perhaps billions of years. Ice that had been sealed in the comet's interior, protected from cosmic rays and solar radiation, suddenly began to sublimate, releasing ancient gases and dust into space. This was like opening a sealed time capsule, revealing preserved samples from the dawn of our solar system. Each fragment became its own source of information, its own transmitter of data about the comet's composition and history. The observation of Atlas's fragmentation by telescopes around the world created a global moment of shared attention. Amateur astronomers stayed up late to capture images of the disintegrating comet, sharing their observations on social media, contributing to a collective documentation of this cosmic event. Professional observatories allocated precious telescope time to study the fragmentation process, gathering data that would be analysed for years to come. Space telescopes above Earth's atmosphere captured details invisible from the ground, adding their observations to the growing archive of information about Atlas. This collective human observation of Atlas mirrors our speculation about the comet's observation of Earth. Just as we gathered information about the comet through multiple channels and from multiple perspectives, so too might the comet have gathered information about our world through the various physical interactions available to it. The difference, of course, is that we consciously chose to observe Atlas, directed our instruments toward it, actively sought to extract information from the photons and particles it emitted. The comet's observation of Earth, if it occurred, would have been passive, automatic, a consequence of physical laws rather than intentional curiosity. Yet this distinction between active and passive observation might be less clear than it appears. When you observe something, when photons from an object strike your retina and generate neural signals that your brain interprets as an image, are you actively observing or passively receiving? The photons would have travelled from the object to your eye, whether you were consciously looking or not. Your brain would have processed the signals whether you were paying attention or not. Consciousness and intention might affect how we interpret and remember observations, but the physical process of observation, the exchange of information through particle and wave interactions, occurs regardless of awareness or intent. As you drift deeper into the borderland between waking and sleep, consider how you are being observed right now, not by conscious entities but by the universe itself. Every photon you emit, every gravitational wave generated by your movements, every particle that interacts with your body, all of these constitute observations, exchanges of information that propagate outward into space and time. You're constantly broadcasting information about yourself into the cosmos, creating ripples in the electromagnetic and gravitational fields that extend, in principle, to the edge of the observable universe. In this sense, you're always under observation, always being recorded in the quantum memory of the cosmos, your existence permanently woven into the fabric of reality. The warmth of your bed, the softness of your pillow, the rhythm of your breathing, all of these sensations are themselves forms of observation, your nervous system gathering information about your immediate environment and transmitting it to your brain. But the flow of information doesn't stop at your skin. The infrared radiation from your body heat passes through your blankets, through your walls, through the atmosphere, and into space, carrying information about your temperature, your metabolic rate, your state of rest or activity. Some tiny fraction of this radiation might have reached Atlas during its passage, might have been absorbed by its ice, might have contributed in some infinitesimal way to the comet's record of its encounter with Earth. This interconnectedness through observation, this constant exchange of information between all parts of the universe suggests a cosmos that is far more unified and integrated than our everyday experience suggests. We tend to think of ourselves as isolated individuals separate from the world around us, but physics tells us this is an illusion. We are patterns of matter and energy in constant interaction with our environment, temporary arrangements of atoms that are constantly exchanging particles with our surroundings. The boundary between self and world, between observer and observed, is not a fixed barrier but a fluid interface where information flows in both directions. The contemplation of Atlas as a potential cosmic recording device leads us naturally into one of the most fascinating frontiers of modern physics. The idea that information might be stored in ways we're only beginning to understand. As you rest there in the quiet darkness, your mind drifting between wakefulness and sleep, consider the possibility that the universe itself might be a vast information storage system, encoding data in the quantum states of particles, in the structure of space-time, in the crystalline lattices of ice drifting through the cosmic void. This isn't science fiction or mystical speculation, but a serious area of scientific inquiry, one that challenges our most basic assumptions about the nature of reality and our place within it. The ice that composed Atlas before its fragmentation was not simply frozen water, but a complex matrix of molecules arranged in crystalline patterns of extraordinary intricacy. At the temperatures found in the outer solar system and beyond, ice can form structures that don't exist naturally on Earth, exotic phases with names like ice 15 and amorphous ice. Each of these phases has different properties, different ways of arranging water molecules, different capacities for incorporating other substances into their crystal lattices. The ice in Atlas likely contained multiple phases, layers of different structures formed under different conditions, each potentially capable of storing information in its own unique way. Think about how we store information in our modern technology. A computer hard drive uses magnetic fields to encode ones and zeros, with each bit of information represented by the orientation of magnetic domains in a thin film of material. But nature has been storing information far longer than humans have existed, using mechanisms that make our technology seem primitive by comparison. DNA stores the instructions for building and operating living organisms in sequences of just 4 chemical bases, achieving storage densities that far exceed anything we've created artificially. Crystals store information in their defects and dislocations, preserving records of the temperatures and pressures under which they formed. Even empty space itself, according to quantum field theory, seethes with virtual particles that encode information about the quantum vacuum. The possibility that cometary ice might store information isn't just theoretical speculation. We know that when cosmic rays strike ice, they create cascades of secondary particles that leave permanent tracks in the crystalline structure. These tracks, called latent tracks, can persist for millions of years, preserving a record of the cosmic ray's energy, direction, and the time of impact. Scientists have used similar tracks in ancient minerals to study the history of cosmic ray exposure on Earth and in meteorites. If Atlas's ice contained such tracks, they would constitute a kind of cosmic ray telescope, recording the radiation environment through which the comet travelled over millions of years. But cosmic ray tracks are just the beginning. Every photon absorbed by the ice changes the electronic state of molecules, potentially creating color centers, trapped electrons, and other quantum states that can persist indefinitely at low temperatures. These quantum states don't just store information about the photon that created them, they can also be influenced by subsequent electromagnetic fields, creating a kind of quantum palimpsest where new information is written over old, where the history of electromagnetic exposure creates complex patterns in the ice's quantum structure. The longer the ice remains in space, exposed to the full spectrum of cosmic phenomena, the richer and more complex this quantum record becomes. The organic molecules we know exist in comets add another dimension to this information storage potential. These aren't just simple compounds but complex polymers, chains of carbon and other atoms that can encode information in their sequences just as DNA encodes genetic information. When these molecules are exposed to radiation, they can polymerize further, creating even more complex structures. Some scientists have suggested that comets might have delivered the precursor molecules for life to early Earth. But what if they also delivered information, cosmic data encoded in molecular sequences that we haven't yet learned to read? As Atlas approached the inner solar system, it entered regions of space where the electromagnetic environment was dramatically different from the quiet darkness of the Oort cloud. The solar wind, that stream of charged particles constantly flowing from the sun, creates a complex, dynamic electromagnetic environment that extends throughout the solar system. This isn't just a uniform flow, but a turbulent, chaotic medium full of waves, shocks, and magnetic structures. As Atlas moved through this environment, its ice would have been exposed to rapidly varying electromagnetic fields that could induce currents in any conductive materials in the comet, create chemical changes in its ice, and add new layers of information to whatever records it already carried. The interaction between Earth's magnetosphere and the solar wind creates particularly interesting electromagnetic phenomena that Atlas would have experienced during its passage. Our planet's magnetic field carves out a cavity in the solar wind, a protective bubble that shields us from the worst of solar radiation. But this interaction also creates complex wave phenomena, Whistler waves, Alfvén waves, and other oscillations that propagate through the plasma environment around Earth. These waves carry information about our planet's magnetic field, about the state of our upper atmosphere, about the interaction between our technological civilization and the space environment. If Atlas's ice could record electromagnetic waves, it might have captured these complex signals, these electromagnetic fingerprints of our world. Consider the implications of quantum entanglement for information storage in cometary ice. When a photon from Earth is absorbed by a molecule in Atlas, the quantum states of the photon and molecule become entangled, creating a quantum correlation that, according to our current understanding of physics, persists regardless of the subsequent separation between Earth and the comet. This doesn't mean we could use this entanglement for faster-than-light communication. That's prohibited by the no-communication theorem of quantum mechanics. But it does mean that information about Earth becomes fundamentally woven into the quantum state of the comet, creating connections that transcend classical notions of space and separation. The fragmentation of Atlas takes on new meaning when viewed through this lens of quantum information. When the comet broke apart, it wasn't just physical matter that was dispersed, but also whatever quantum information might have been encoded in its ice. Each fragment would carry its own portion of this information, like pages torn from a quantum book. Some of these fragments continued toward the sun, where they completely sublimated, releasing their information into the solar wind to be carried outward to the stars. Others were deflected onto new orbits, perhaps to return to the outer solar system carrying their quantum records with them, perhaps to encounter other worlds where their information might be deposited or transformed. The timing of Atlas's visit to the inner solar system coincided with an unprecedented period in human history. Not just the global pandemic, but also the height of our electromagnetic output as a civilization. Never before have we been generating and transmitting so much information, Never before have our electromagnetic emissions been so complex and varied. From the billions of cell phones constantly communicating with towers and satellites, to the vast data centers processing and storing our digital lives, to the countless IoT devices monitoring and reporting on every aspect of our environment, we've created an electromagnetic cacophony that would be clearly distinguishable from any natural phenomena. If there was ever a time when a passing comet might record clear evidence of a technological civilization on Earth, it would be now. But what exactly would such a recording look like? We shouldn't imagine neat digital files or analog recordings like those we create with our technology. The information stored in cometary ice, if it exists, would be encoded in quantum states, in molecular arrangements, in crystal defects, in a myriad of physical phenomena that we might not even recognize as information storage. It might be more like the way a forest encodes information about past climate in tree rings, or the way sedimentary rocks encode information about ancient seas in their layers. The information would be there, but reading it would require understanding the language in which it's written, the physical processes that created the recording. This brings us to a profound realization about the nature of information in our universe. Information isn't something separate from physical reality. It is physical reality. Every particle, every field, every quantum state is essentially information, data about the state of the universe at that point in space and time. When we talk about Atlas potentially recording information about Earth, we're not talking about something exotic or unusual. We're talking about the fundamental nature of physical interaction, the way information is exchanged whenever any two parts of the universe interact. The only question is whether this information is preserved in a form that could, in principle, be retrieved and decoded. The organic chemistry of comets provides particularly intriguing possibilities for information storage. We know that comets contain amino acids, the building blocks of proteins and other complex organic molecules. These molecules can form polymers, long chains that could encode information in their sequences. When exposed to radiation, these polymers can cross-link, creating three-dimensional networks of extraordinary complexity. Some scientists have speculated that such networks might even be capable of primitive information processing, chemical computation that could transform and organize the information they store. This is highly speculative, of course, but it illustrates the rich possibilities for information storage and processing in what might appear to be simple ice and rock. The possibility that information about Earth might be preserved in cometary ice raises fascinating questions about the persistence of information in the universe. We tend to think of information as fragile, easily lost or corrupted. Our digital devices fail, our memories fade, our records decay. But quantum mechanics suggests that information, at the most fundamental level, cannot be destroyed. It can be scrambled, it can be dispersed, it can become practically irretrievable, but it cannot simply vanish. This principle, known as unitarity, implies that everything that has ever happened, every event, every thought, every dream, has left a permanent mark on the universe, even if that mark is too faint or too scrambled for us to read. As you lie there in the darkness, perhaps you can sense the faint electromagnetic fields that surround you, the radio waves passing through your body, the magnetic field of Earth that extends far beyond our atmosphere. All of these fields carry information. All of them are constantly interacting with matter, potentially leaving traces, creating records. Your own thoughts generate electromagnetic fields, tiny but real, that propagate outward from your brain at the speed of light. These fields are incredibly weak, far too weak to be detected at any significant distance with our current technology. But they exist. They're real. They carry information about the electrical activity of your neurons, and in principle, they extend infinitely into space, becoming part of the cosmic electromagnetic environment. The idea that Atlas might have recorded something of our electromagnetic emanations becomes less fantastic when we consider the sensitivity of quantum systems to electromagnetic fields. A single photon can change the state of an atom, A weak magnetic field can affect the spin of an electron. Tiny variations in electric fields can influence chemical reactions. The ice in Atlas, exposed to the electromagnetic environment of the inner solar system for months, would have been constantly influenced by these fields, its quantum states subtly modified, its molecular arrangements potentially altered. Whether these influences constitute a readable record is unknown, but the physical interaction certainly occurred. The sublimation of ice from Atlas as it approached the Sun created a natural amplification process for any information that might have been stored in the comet's surface layers. As ice turned directly to gas, molecules that had been locked in place for millions of years were suddenly free to move, to interact, to recombine. If these molecules carried information in their quantum states or molecular structures, that information would have been released into the coma, the cloud of gas and dust surrounding the comet. Some of this material would have been swept away by the solar wind, carrying any encoded information with it. Some would have fallen back onto the nucleus, potentially creating new chemical reactions, new opportunities for information processing and storage. The spectroscopic observations of Atlas made by Earth-based telescopes revealed the presence of various molecules in its coma. Water, of course, but also carbon monoxide, carbon dioxide, methane, ammonia, and more complex organic compounds. Each of these molecules tells a story about the comet's origin and history, about the conditions in the early solar system, about the chemical processes that have shaped our cosmic neighborhood. But might they also carry more subtle information, quantum states influenced by their interaction with Earth's electromagnetic emissions, molecular arrangements modified by their exposure to our planet's influence? We don't know. We may never know. But the possibility adds a layer of wonder to our contemplation of this cosmic visitor. The trajectory of Atlas brought it within about 0.25 astronomical units of Earth at its closest approach, roughly 37 million kilometers. At this distance, the electromagnetic signals from our planet would have been relatively strong, certainly detectable with sensitive instruments. The inverse square law tells us that the intensity of electromagnetic radiation decreases with the square of distance, so at 37 million kilometers, Earth signals would have been about 10,000 times weaker than they are at Earth's surface. This might seem like a huge reduction, but remember that we routinely detect signals from spacecraft billions of kilometers away, signals far weaker than what Earth as a whole emits. The electromagnetic voice of our planet would have been clearly audible to Atlas, if it had the means to listen. But of course, Atlas didn't have instruments, or consciousness, or any ability to actively listen. If it recorded information about Earth, it did so passively, automatically, through the fundamental physical processes that govern the interaction of matter and radiation. This passive recording might seem less interesting than active observation, but in some ways it's more profound. It suggests that the universe itself is constantly recording everything that happens, not because it chooses to or wants to, but because that's simply what physical interaction means, the exchange and preservation of information. The fragments of Atlas continue their journey through the solar system even now, some falling toward the Sun, others heading back to the outer darkness. Each fragment carries with it whatever information might have been encoded in its ice, whatever records of its long journey through space and its brief encounter with the inner solar system. Some of these fragments will completely sublimate, releasing their information into the solar wind. Others might survive, might eventually return to the Oort cloud, might even be ejected from the solar system entirely, carrying their records to the stars. The story of Atlas, in this sense, is not over, but has simply entered a new chapter, one of dispersal and transformation rather than coherent travel. As we contemplate the possibility that Atlas might have recorded information about Earth, we're really contemplating something much larger, the idea that the universe might be full of such records, that every comet, every asteroid, every grain of cosmic dust might carry information about its journey, about the worlds it has encountered, about the stars it has passed. If this is true, then space is not empty but full of information, a vast library of cosmic history written in ice and rock and dust. We have only just begun to learn how to read this library, to decode the information preserved in meteorites and comet samples. What stories might we discover as we develop better techniques for reading these cosmic records? The gentle darkness of your room, the soft rhythm of your breathing, the gradual slowing of your thoughts as sleep approaches, all of this is part of the same cosmic process of information exchange that might have allowed Atlas to record something of our world. You're not separate from this process, but immersed in it, participating in it with every heartbeat, every breath, every fleeting thought. The electromagnetic fields generated by your body, weak as they are, extend into space, joining the chorus of signals from all of humanity, all of life, all of Earth. Somewhere out there, perhaps encoded in the ice of a comet or the minerals of an asteroid, there might be a faint record of this moment, of you lying here, contemplating the cosmos and your place within it. The possibility that we're being recorded by the universe itself might seem unsettling or comforting depending on your perspective. There's something humbling about the idea that our actions, our thoughts, our very existence might be preserved in forms we don't understand, in places we'll never visit. But there's also something profound about it, something that connects us to the larger cosmos in an intimate way. We're not isolated beings on an isolated world, but part of a vast network of information exchange that spans the universe. Every photon that leaves Earth carries information about us into the cosmos. Every particle that escapes our atmosphere becomes an ambassador of our world. Every gravitational wave generated by our movements propagates to the edge of space and time. The electromagnetic symphony that Earth broadcasts into the cosmos is unlike anything that has existed in our planet's 4.5 billion year history. As you rest there in the gentle darkness, surrounded by the invisible signals from countless devices, you are part of a phenomenon that would seem like magic to anyone living just a century ago. Our world has become a beacon in the electromagnetic spectrum, singing a complex song of civilization into the void. And if Atlas, during its passage through our neighborhood, could somehow record these emanations, what a remarkable archive it would have collected. What an extraordinary snapshot of humanity at this unique moment in our technological evolution. Consider the layers of signals that emanate from Earth at any given moment. At the lowest frequencies, there's the hum of our power grids, a steady 50 or 60 hertz pulse that would immediately identify Earth as a planet with organized electrical infrastructure. This isn't a natural frequency. Nothing in nature produces such a regular, sustained electromagnetic pulse at these specific frequencies. It's a clear signature of technology, of a civilization that has learned to harness and distribute electrical energy on a planetary scale. The strength of this signal has been growing exponentially since the early 20th century, transforming Earth from an electromagnetically quiet world to one that announces its technological presence to anyone or anything capable of detecting these frequencies. Moving up the electromagnetic spectrum, we find the rich complexity of radio communications. AM radio stations broadcasting news, music, and conversation in hundreds of languages. FM stations with their higher fidelity signals carrying the cultural expressions of thousands of communities around the globe. Television broadcasts painting moving pictures in electromagnetic waves, encoding not just sound but images, stories, the visual culture of our species. Each of these signals radiates outward from its transmission point, spreading like ripples on a cosmic pond, carrying information about who we are, what we value, how we see ourselves and our world. But it's in the higher frequencies that the true complexity of our electromagnetic emissions becomes apparent. Cellular communications create a constantly shifting pattern of signals as billions of phones connect to towers, transmit data, stream videos, send messages. Each phone is a tiny transmitter, its signal weak individually, but part of a vast network that blankets populated areas with electromagnetic energy. Wi-Fi routers in homes and businesses add another layer, creating bubbles of connectivity that overlap and interfere. generating a complex electromagnetic texture that would be utterly unique to a technological civilization. Bluetooth devices, satellite communications, GPS signals, radar systems all contribute their own frequencies and patterns to the electromagnetic cacophony that surrounds our planet. The content of these signals, if it could somehow be decoded from the hypothetical recordings in Atlas's ice, would tell an incredible story about humanity in the early 21st century. Our news broadcasts would reveal our concerns and conflicts, our struggles with pandemic and climate change, our political divisions and social movements. Our entertainment would showcase our creativity and imagination, our myths and stories, our humor and fears. Our personal communications, the billions of text messages and phone calls and video chats, would paint an intimate portrait of human relationships, of love and loss, of daily struggles and small triumphs, of the full range of human experience in all its complexity and contradiction. During Atlas's passage through the inner solar system in early 2020, these signals would have carried particularly poignant information. The world was in the grip of a pandemic, and our electromagnetic emissions reflected this unprecedented global experience. Video calls replaced in-person meetings, creating new patterns of data transmission. Location tracking from phones showed the dramatic changes in human movement patterns as lockdowns were implemented. Social media platforms buzzed with information and misinformation about the virus, creating electromagnetic patterns that encoded humanity's collective response to crisis. If there was ever a time when Earth's electromagnetic signature would clearly indicate a global civilization facing a common challenge, it was during Atlas's visit. The scientific data we transmit would be particularly interesting from the perspective of a hypothetical cosmic archaeologist examining Atlas's records. Our deep space communications with robotic spacecraft exploring the solar system would show that we're not just bound to Earth, but actively exploring our cosmic neighborhood. The signals from radio telescopes would reveal our curiosity about the universe, our search for other civilizations, our attempt to understand our place in the cosmos. Weather satellites constantly transmitting data about atmospheric conditions, Earth observation satellites monitoring forests and oceans and ice caps, all of this would paint a picture of a species that has developed the capability to observe and understand its own planet from space. But perhaps most remarkably, the signals from our internet infrastructure would encode the sum of human knowledge as it exists in our digital age. Every Wikipedia article accessed, every scientific paper downloaded, every online course streamed, all of this information radiates into space as electromagnetic waves. It's a constantly updating encyclopedia of human understanding, a real-time record of what we know and how we think about the world. If this information could somehow be preserved in the quantum states of cometary ice, Atlas would carry with it not just observations of Earth, but the actual content of human civilization, our languages, our mathematics, our science, our history, our art. The Internet of Things adds yet another layer to our electromagnetic emanations. Smart homes with connected thermostats, light bulbs, and appliances, each generating its own small contribution to the electromagnetic chorus. Fitness trackers, monitoring heartbeats and counting steps, their data transmitted to phones and then to servers. Smart cities with sensors monitoring traffic flow, air quality, energy usage. Industrial IoT devices tracking manufacturing processes, supply chains, agricultural conditions. All of these devices are constantly communicating, creating a fine-grained electromagnetic map of human activity that would be unprecedented in its detail and scope. The electromagnetic pulse of our financial systems would tell its own story. Every credit card transaction, every stock trade, every cryptocurrency mining operation generates electromagnetic signals that encode economic activity. The high-frequency trading algorithms that now dominate financial markets create patterns of electromagnetic emission that would be clearly artificial, impossibly fast and complex for any natural phenomenon. An analysis of these signals would reveal not just that Earth hosts a technological civilization, but that this civilization has developed abstract systems of value and exchange, digital representations of wealth that exist only as patterns of information in electromagnetic fields. Our military and defense communications add another distinctive element to Earth's electromagnetic signature: encrypted signals that would appear as structured but indecipherable patterns, radar systems constantly scanning for threats, communications between aircraft and ground control, submarine communications using extremely low frequencies that can penetrate deep into the ocean. These signals would indicate not just technology but organization, hierarchy, the existence of nation-states and military forces. They would suggest a civilization advanced enough to pose threats to itself, requiring sophisticated systems of defense and deterrence. The electromagnetic emissions from our space activities would be particularly relevant to Atlas's journey. Satellite communications create a shell of signals around Earth, extending far into space. The Deep Space Network, with its massive dishes communicating with spacecraft throughout the solar system, sends focused beams of information that would be detectable from enormous distances. The International Space Station, with its constant communication with ground control, its experiments transmitting data, its crew members making video calls to Earth, creates its own unique electromagnetic signature, orbiting above our planet. These signals would clearly indicate that we're not just a surface-bound civilization, but one that has begun to expand into space. Consider the electromagnetic signatures of our scientific instruments, the tools we use to understand the universe. Particle accelerators generating intense electromagnetic fields as they probe the fundamental structure of matter. Radio telescopes listening to the cosmos, but also occasionally transmitting, sending messages to specific stars in hopes of contact with other civilizations. Medical equipment like MRI machines, creating powerful magnetic fields to image the human body. Scientific satellites studying the sun, the magnetosphere, the cosmic rays that constantly bombard our planet. Each of these instruments adds its own voice to Earth's electromagnetic chorus, contributing to a signature that would clearly indicate a civilization engaged in scientific inquiry. The cultural content of our electromagnetic emissions would be fascinating from an outside perspective. Music from every culture and tradition encoded in radio waves and streaming services. Movies and television shows depicting our stories, our values, our fears and aspirations. Podcasts and audiobooks preserving our oral traditions in digital form. Video games creating interactive narratives that would seem utterly alien to a civilization without such technology. All of this cultural production radiates into space, carrying the creative output of billions of humans into the cosmos. If Atlas could somehow record these signals, it would carry with it an archive of human culture at a specific moment in our history. Educational content forms another significant component of our electromagnetic emissions. Online universities broadcasting lectures, students accessing digital libraries, virtual classrooms connecting teachers and learners across vast distances. The pandemic particularly amplified these signals as education moved online globally, creating new patterns of electromagnetic emission as billions of students attended classes through screens. This would indicate not just intelligence, but the transmission of knowledge across generations, the hallmark of a civilization that builds upon its past rather than starting fresh with each generation. The electromagnetic signatures of our transportation systems tell the story of a mobile civilization. Aircraft transponders constantly broadcasting position and altitude, creating a three-dimensional map of air traffic around the globe. Ships with their automatic identification systems, trains with their communication and control systems, automobiles increasingly connected to cellular networks and GPS satellites. Even our shift toward electric vehicles creates new electromagnetic patterns as charging stations proliferate and battery management systems communicate with the grid. These signals would reveal patterns of movement, trade routes, the circulation of goods and people that keeps our global civilization functioning. Our emergency and public safety communications create distinctive electromagnetic patterns that would indicate a civilization that cares for its members. Emergency calls to police, fire and medical services, disaster response communications coordinating relief efforts, amber alerts searching for missing children, weather warnings transmitted to millions of phones simultaneously. These signals would suggest not just technology but values, a society that has created systems to protect and assist its vulnerable members. The electromagnetic signature of compassion and mutual aid, encoded in radio waves and cellular signals. The electromagnetic emissions from our homes would paint an intimate picture of daily life on Earth. Smart speakers listening for wake words and responding to queries, baby monitors transmitting audio and video, security systems detecting motion and sending alerts, kitchen appliances downloading recipes, television streaming content, gaming consoles connecting players around the world. Each home becomes a node in a vast network of electromagnetic emission, contributing its small part to the planetary signal that radiates into space. The rhythms of these emissions, following daily and weekly patterns as people wake, work, relax and sleep, would reveal the temporal structure of human life. As you lie there in the darkness, your own devices contribute to this electromagnetic symphony. Your phone periodically checking for messages even as you rest, your Wi-Fi router maintaining its connection to the internet, perhaps a fitness tracker monitoring your sleep patterns. You are surrounded by and participating in this invisible conversation, this constant exchange of information that has become so fundamental to modern life that we rarely notice it. Yet from the perspective of the cosmos, from the hypothetical viewpoint of Atlas, as it passed through our neighborhood, this would be the most remarkable thing about Earth, more distinctive than our blue oceans or green continents, more indicative of our unique status as a technological civilization. The scientific instrumentation we've developed to study comets like Atlas generates its own category of electromagnetic emissions. Ground-based telescopes with adaptive optic systems constantly adjusting to compensate for atmospheric distortion, space telescopes transmitting their observations back to Earth, computer networks processing and analyzing the data. The Very Large Array in New Mexico, the Atacama Large Millimeter Array in Chile, the Event Horizon Telescope network that spans the globe. All of these instruments contribute to Earth's electromagnetic signature while simultaneously trying to understand visitors like Atlas. There's a beautiful symmetry in this, the observer and the observed both potentially recording information about each other. The electromagnetic emanations from our research facilities would indicate a civilization pushing the boundaries of knowledge. CERN's Large Hadron Collider, generating some of the most intense electromagnetic fields ever created by humans as it accelerates particles to near light speed. Fusion research facilities attempting to recreate the conditions inside stars, their magnetic confinement systems creating electromagnetic signatures unlike anything in nature. Quantum computing laboratories, where researchers manipulate individual atoms and photons, creating and destroying quantum states that might, in their own small way, contribute to the information that radiates from our planet. Our electromagnetic emissions also carry evidence of our impact on the planet. The reduced emissions during pandemic lockdowns would have created a detectable change in Earth's electromagnetic signature, a sudden quieting of certain frequencies as transportation decreased and industry shut down. The electromagnetic noise from mining operations extracting the rare earth elements needed for our electronics, the signals from offshore oil platforms and wind farms, the communications coordinating global supply chains that move resources around the planet. All of this would paint a picture of a civilization that has profoundly altered its homeworld, for better and worse. The content of our news broadcasts during Atlas's passage would have captured a remarkable moment in human history. Reports of a novel virus spreading across the globe, governments implementing unprecedented lockdowns, scientists racing to develop vaccines, economic uncertainty, social unrest, political upheaval, but also stories of resilience, of communities coming together despite physical distance, of scientific achievement and human ingenuity in the face of crisis. If these broadcasts could somehow be preserved in Atlas's ice, they would provide future archaeologists with an incredibly detailed record of how humanity responded to a global challenge. Our entertainment emissions during this period would be equally telling. The explosion of streaming content as people stayed home, binge-watching series and movies, virtual concerts and performances as artists found new ways to reach audiences, online gaming experiencing unprecedented growth as people sought social connection through digital means, the electromagnetic patterns of a civilization adapting its culture to new constraints, finding ways to maintain human connection and creativity despite physical isolation. These signals would reveal not just our technology, but our humanity, our need for stories and music and play, even in difficult times. The electromagnetic signatures of our social media platforms would provide a real-time record of human thought and emotion during Atlas's passage. Billions of posts, comments, likes, and shares, each generating tiny electromagnetic pulses as they're transmitted from devices to servers and back out to other devices. The viral spread of information and misinformation, the formation of online communities, the digital protests and movements that shaped public discourse. This would be the most granular record of human consciousness ever created, a moment-by-moment account of what billions of people were thinking and feeling. Consider the electromagnetic emanations from our hospitals and medical facilities during early 2020. Medical equipment working overtime, ventilators keeping patients alive, monitoring systems tracking vital signs, telemedicine appointments replacing in-person visits, creating new patterns of data transmission, research laboratories sequencing viral genomes and sharing data globally at unprecedented speed. The electromagnetic signature of a global health system under strain, but also showcasing the remarkable capabilities of modern medicine. These signals would tell the story of a species capable of understanding and fighting disease at the molecular level. The electromagnetic emissions from our educational institutions shifting online would have created unique patterns during Atlas's visit. Millions of students attending virtual classes, accessing online libraries, submitting digital assignments, the electromagnetic signature of knowledge transmission adapting to new circumstances, of human culture ensuring its continuity despite physical separation. These signals would indicate not just current technology but investment in the future, a civilization that prioritizes the education of its young, even in times of crisis. Our religious and spiritual practices also contribute to Earth's electromagnetic signature. Services and prayers broadcast over radio and internet, meditation apps guiding millions through mindfulness exercises, online communities gathering for virtual ceremonies, the electromagnetic encoding of humanity's spiritual life, our search for meaning and connection to something greater than ourselves. These signals would reveal that we're not just material beings, but creatures that seek transcendence, that create rituals and meanings beyond mere survival. The electromagnetic emanations from our artistic communities would paint a picture of human creativity. Digital art being created and shared, music being produced in home studios and distributed globally, writers collaborating across continents through shared documents. The electromagnetic signature of human imagination, of our irrepressible need to create beauty and a meaning. These signals would show that even in isolation, even in crisis, humans continue to make art, to tell stories, to express the inexpressible through creative acts. As Atlas receded from the inner solar system, breaking apart as it went, it would have carried with it this incredible electromagnetic portrait of Earth at a unique moment in our history. Every fragment potentially holding some portion of this record, some quantum impression of our world's electromagnetic voice. Some fragments falling sunward, their information content sublimating into space. Others heading back to the cold darkness. perhaps to return centuries or millennia hence, still carrying their encrypted observations of our moment in time. The possibility that our electromagnetic emissions might be recorded in cometary ice or cosmic dust raises profound questions about privacy and permanence in the universe. Every signal we generate, every bit of information we transmit, potentially becomes part of the permanent record of the cosmos. Our most private conversations, our most personal data, our collective secrets and individual thoughts, all of it radiating outward at the speed of light, potentially being absorbed and recorded by passing cosmic objects. We are, in a very real sense, broadcasting ourselves to the universe, creating an electromagnetic autobiography of our species that we cannot recall or edit. Yet there's something beautiful about this cosmic transparency, this inability to hide our electromagnetic emanations from the universe. It means that we are truly part of the cosmic conversation, that our voices, however small, contribute to the electromagnetic symphony of the cosmos. Every radio wave we generate joins the vast chorus of natural radio emissions from stars, pulsars, and galaxies. Our artificial signals become part of the universe's information content, adding complexity and meaning to the cosmic electromagnetic environment. The technical details of how electromagnetic signals might be recorded in cometary ice remain speculative, but the physical principles are sound. Electromagnetic waves can induce chemical changes, can affect crystal structures, can influence quantum states. The ice in Atlas, exposed to Earth's electromagnetic emissions for months, would have been constantly bathed in these signals, constantly influenced by them at the molecular and quantum level. Whether these influences constitute a readable record is unknown, but the interaction certainly occurred. The information was certainly exchanged. As you drift towards sleep, consider that the electromagnetic emissions from your own life, weak as they are, have joined this cosmic broadcast. Every phone call you've made, every message you've sent, every video you've watched has contributed in some small way to Earth's electromagnetic signature. Your digital footprint extends not just across the internet but into space itself, becoming part of the permanent electromagnetic record of our planet. In this sense, you are not just an observer of the cosmos, but an active participant in its information ecology, a voice in the cosmic chorus that sings Earth's story to the stars. The fragments of Atlas continue their journeys through space, each potentially carrying its portion of whatever electromagnetic records might be encoded in its ice. Some will return to the Oort cloud, that vast repository of cometary nuclei that surrounds our solar system. There, in the cold darkness, they might preserve their records for millions of years, waiting for another gravitational perturbation to send them falling back toward the sun. Others might be ejected from the solar system entirely, carrying their information to interstellar space, becoming messengers from Earth to distant stars we will never visit. The Great Silence, as it's called in discussions of the Fermi paradox, refers to the puzzling absence of obvious signals from extraterrestrial civilizations. Given the vast number of stars in our galaxy, the billions of years available for life to evolve, and the relative ease of interstellar communication via radio waves, why don't we detect signals from other technological civilizations? This question has haunted astronomers and philosophers since Enrico Fermi first articulated it in 1950, and it becomes even more perplexing as we discover more and more potentially habitable planets orbiting other stars. But what if the silence isn't really silence at all? What if the universe is full of information, full of signals and records and messages, but we simply haven't learned how to detect them, how to read them, how to recognize them for what they are? The possibility that comets like Atlas might carry information about the worlds they've encountered suggests a different kind of cosmic communication, one that doesn't rely on electromagnetic broadcasts or deliberate signals, but on the natural movement of objects through space, the passive recording of information in ice and rock and dust. Consider the implications of this idea. Every comet that passes through a solar system potentially records information about the worlds it encounters. Every asteroid that's ejected from one system and captured by another might carry with it records of its original home. Every grain of interstellar dust that drifts between the stars might hold quantum information about the places it's been, the phenomena it's witnessed. If this is true, then space isn't empty and silent but full of messages, a vast library of cosmic information encoded in the material objects that wander between the stars. This would represent a fundamentally different kind of cosmic communication than what SETI researchers have traditionally looked for. Instead of powerful radio beacons or laser pulses deliberately sent by advanced civilizations, we might have a natural, automatic system of information exchange mediated by the movement of material objects through space. Comets and asteroids become the universe's postal service, carrying messages between star systems not through intention, but through the natural processes of orbital dynamics and physical interaction. The Oort cloud, from which Atlas originated, might be particularly important in this context. This vast spherical shell of icy objects extends perhaps halfway to the nearest star, and similar clouds likely surround other stellar systems. These clouds aren't isolated but can interact when stars pass close to each other, exchanging comets like cosmic calling cards. Over the billions of years of galactic evolution, countless such exchanges have occurred, creating a complex network of material and potentially informational connections between star systems. If comets can record information about the worlds they encounter, then the Oort cloud might be a vast repository of information about not just our solar system but others as well. Some of the comets in our Oort cloud might have originated in other stellar systems, been captured by our sun's gravity during close stellar encounters. These interstellar immigrants might carry with them records of their original homes, information about other worlds encoded in their ice. Every comet that falls from the Oort cloud toward the sun might be bringing us information from across space and time, messages we haven't yet learned to read. The discovery of Oumuamua in 2017 and 2I Borisov in 2019, the first confirmed interstellar objects to pass through our solar system, adds weight to this possibility. These objects definitely came from other star systems, and if the principle of information recording in cosmic objects is valid, they might carry records of their home systems and their journeys through interstellar space. Oumuamua's unusual properties, its elongated shape and non-gravitational acceleration, sparked speculation about artificial origins, but even if it's entirely natural, it might still be carrying information about another star system in ways we don't yet understand. This perspective transforms our understanding of what the Great Silence might mean. Perhaps civilizations don't need to broadcast powerful radio signals to communicate across interstellar distances. Perhaps they don't build megastructures or create other techno-signatures we can detect from Earth. Perhaps the universe has its own communication system, based on the exchange of material objects that naturally record and carry information. Civilizations might learn to read these cosmic messages, to decode the information carried by comets and asteroids, to access the vast library of cosmic history encoded in ice and rock. The fragmentation of Atlas takes on new meaning in this context. If the comet was carrying information from other parts of the solar system or beyond, its breakup didn't destroy this information but distributed it, scattered it across multiple carriers. It's like taking a book written in an unknown language and tearing it into pieces, each piece still containing part of the text even if we can't read it. The fragments of Atlas, each following slightly different orbits, each potentially encountering different futures, multiply the possibilities for information transmission and preservation. Consider the timescales involved in this kind of cosmic communication. A comet ejected from one star system might take millions of years to reach another. The information it carries would be ancient by the time it arrives, a message from the deep past rather than a real-time communication. But for the universe, operating on timescales of billions of years, this might be perfectly adequate. Civilizations that think in geological or astronomical timescales rather than human lifespans might find such slow communication entirely acceptable, even preferable to the ephemeral nature of electromagnetic signals that disperse and weaken with distance. The idea that the universe might be full of unread messages, unrecognized signals, uninterpreted information is both frustrating and exciting. It suggests that we might be surrounded by evidence of other worlds, other civilizations, other forms of life, but we simply haven't developed the tools or understanding to recognize and decode this evidence. Every meteorite that falls to Earth, every comet we observe, every grain of cosmic dust we collect might be carrying information we can't yet access. We're like pre-literate people surrounded by books, aware that they're important but unable to read the messages they contain. This also suggests that our own messages, the information Earth broadcasts electromagnetically and potentially records in passing comets, might eventually reach other worlds, other civilizations. Atlas, or objects like it, might carry information about Earth to distant star systems, delivering a record of our world to beings we'll never meet. Our electromagnetic emissions, encoded in cometary ice, might be decoded by alien scientists millions of years in the future, providing them with a glimpse of Earth during the early 21st century, a snapshot of a young technological civilization taking its first steps into space. The possibility of natural automatic information transmission via cosmic objects might explain why we haven't detected obvious artificial signals from other civilizations. If the universe has its own communication system based on the movement and information-carrying capacity of material objects, civilizations might not need to generate powerful electromagnetic signals. They might instead learn to read the messages already being transmitted by comets and asteroids to decode the information naturally recorded in cosmic ice and dust. This would be a more subtle, more integrated approach to cosmic communication, working with natural processes rather than against them. The search for extraterrestrial intelligence might need to expand beyond looking for electromagnetic signals to examining the physical objects that pass through our solar system. Every comet, every asteroid, every meteorite might potentially carry information about other worlds. The challenge is developing the technology and understanding to detect and decode this information. We would need to look beyond chemical composition and physical structure to quantum states, molecular arrangements, patterns and anomalies that might encode information in ways we haven't yet imagined. Atlas itself, or rather its fragments, might still hold secrets we haven't discovered. The spectroscopic observations we made during its passage revealed its basic composition, but there might be subtler information encoded in its ice that our current instruments couldn't detect. Future technology might allow us to examine cometary material at the quantum level, to read information encoded in crystal defects, molecular arrangements, isotope ratios. We might discover that comets have been trying to tell us stories all along, but we haven't known how to listen. The concept of panspermia, the idea that life might spread between worlds via meteorites and comets, takes on new dimensions in this context. If comets can carry information, they might carry not just the chemical building blocks of life, but actual biological information, genetic codes, molecular templates for living systems. Life might spread through the galaxy not just as spores or microorganisms, but as information, instructions for building living systems that could be implemented when conditions are right. Atlas might have been carrying not just water and organic molecules, but coded instructions for life, messages and molecular bottles cast into the cosmic ocean. As you drift deeper towards sleep, consider the profound implications of living in a universe where information is preserved and transmitted in ways we're only beginning to understand. Every interaction leaves a trace. Every observation creates a record. Every event becomes part of the cosmic memory. The universe might be far more interconnected than we imagine, with information flowing between worlds via channels we haven't recognized, messages passing between stars in forms we haven't learned to read. The fragmentation of Atlas might have been not an ending, but a transformation, not a destruction, but a dissemination. The information potentially encoded in its ice, whatever records it might have carried of its encounters with Earth and other worlds, now spread across multiple fragments, each carrying part of the story. Some of these fragments will sublimate completely, releasing their information into the solar wind to be carried to the stars. Others will continue their journeys through the solar system, perhaps to encounter other worlds, perhaps to collect new information to add to their cosmic records. The possibility that we live in a universe full of messages, full of information naturally recorded and transmitted by cosmic objects, transforms our understanding of our cosmic context. We're not isolated on a single world, calling out into an empty void. We're part of a vast network of information exchange, a cosmic conversation that has been going on for billions of years. Every comet that graces our skies might be bringing us messages from distant places and ancient times. Every meteorite that falls to Earth might carry information about other worlds. We just need to learn how to read these messages, to decode the information that surrounds us. The Great Silence might not be silence at all, but a different kind of communication, one that operates on timescales and through mechanisms we're only beginning to appreciate. The universe might be talking to us constantly through the material objects that pass through our solar system, through the comets and asteroids and dust grains that carry information from across space and time. Atlas might have been one such messenger, carrying information we couldn't read, delivering messages we couldn't decode. But its passage reminds us that we're part of something larger, part of a cosmic information network that connects all parts of the universe through the patient movement of matter through space. As sleep begins to claim you, let your mind drift with the fragments of Atlas, scattered now across their individual trajectories. Each fragment carries its portion of cosmic history, its record of a journey from the edge of the solar system to the warmth of the inner planets. Each fragment might hold information about Earth, about our electromagnetic emissions, about our moment in cosmic time. These fragments join the countless other objects wandering through space, each potentially carrying information, each part of the universe's vast and patient postal system. The idea that comets might be cosmic messengers, carrying information between worlds, adds a layer of meaning to every meteor shower, every cometary apparition, every piece of cosmic debris that enters our atmosphere. We might be receiving messages constantly, information from across the galaxy encoded in forms we don't recognize. The shooting star you might have wished upon as a child might have been carrying information from another world, burning up in our atmosphere and releasing its cosmic secrets into the night sky. The universe might be far more talkative than we ever imagined. We just need to learn its language.